everybody, welcome back to another MR Academy math video. And in this one today, we're going to continue on with our little series of circles that we are going through. In the last video, we discussed the circumference of a circle, which is just the distance around the outside of a circle. And today, we're going to get more into what the area of a circle is and how we find that as well. I do highly recommend if you go back just toward the beginning of our last video. I might touch on a couple things a little more in depth today. We might go over radius and diameter a little bit again, but I do go over that in depth in our last video on circumference. So if you do want to check that out, definitely head back, look at that video as well once again, just to make sure that you are definitely caught up on that piece of circles. But like I said, we are going to touch on it one more time today. Not quite as in-depth, but we will touch on it, so you know what we are talking about. But before we really jump in, I do want to thank you for stopping in and checking this video out. If you do enjoy what you are seeing and hearing today, if this video does help you, if it does what you came here for this video to do hit that like button. And if you want to be notified of more videos in the future, hit that subscribe button. I am going to try to make more videos now that it is getting into summer. I've got some more free time on my hands, and I want to try to help all of you out as we get into maybe summer school or as we head into the next school year. So I would truly appreciate that if you would like this video. If it did help you, hit that subscribe button if you want to be notified of future videos as well. So thank you for that. But right now, we're going to jump into area of circles. I'm going to try not to make this one quite as long as the last one. My last video was very, very long. This one, we're going to try to go in depth, but a little bit less time for you. So the area of a circle, the area of any polygon, is just the amount of space that's inside of the shape. If it's a square, it's the area inside of a square. Okay, the space that's inside of a square. If it's a triangle, it's the space that's inside of the triangle, inside of its three sides. If it's an octagon, it's the space that's inside of the 8 sides of the octagon. That's all area is. It's the space on the inside of a two-dimensional shape. Now, in order to find that out, we have to know two pieces of information. First of all, we have to know what the radius is. Right here, this little line, that is our radius. We talked about this a little bit in our last video as well. The radius is more important in finding the area than it was in finding the circumference. Just like the diameter was more important in finding the circumference than the radius. But we can use both of them to find out the area or circumference of a circle. Okay? We're just going to have to use radius more today. So if we know the diameter, we have to go back and find the radius from that. Okay? So we talked about radius, just the distance from the center of a circle to any point on the outside. Could be this, could be from here out to here, could be from here out to here, could be from here out to here. There's an infinite number of points, infinite number of radii that you could draw in this circle. As long as you're going from dead center out to any other point on the outside of that circle, that is a radius. Now the other thing that we do have to know is our pi, which we talked about last time as well. Not the pie that we eat, but the Greek symbol that stands for a number that we use all the time for circles. It's a constant. It's a number that doesn't change. Now for our case, we're just going to use 3.14. And I'm going to write that down here bigger so that we don't forget. Maybe in your math class, you're just using the pi symbol. That's fine. You don't have to multiply whatever we're doing by anything. You can just keep that pi symbol in there. You don't have to use the number. That's fine. In this case, we're going to be using 3.14. Now, it does go on for a long time after that. In fact, they are still finding more and more and more decimals of pi as we're creating this video right now. And it's hard to say when they're going to find all of the decimals. But the number that we're going to use, we're not going to dive too deep into what it is right now. Just remember 3.14 is pi. That's what we're going to use for our case today. Now, sometimes, just like we talked about with circumference, we are not given the radius. Just like in circumference, sometimes we're not given the diameter. Sometimes we are given just the diameter in this case, and we have to find the radius. Well, all we have to do is work backwards. If we are given the diameter, we just have to cut that in half. Okay? That's all it is. Okay, we just cut that number in half. So if the diameter of this circle down here was 14, our radius is half of that, 7. If the diameter is 24, we just cut that in half, radius is 12. That's all you have to do. Okay, just take your diameter divided by 2, that's going to get you your radius. To find the area of a circle, how much space is on the inside of a circle, we're going to use this formula right here. Okay, all of this. Technically, it's only this. Those are two the same thing. Okay, but the area equals pi times whatever our radius is times the radius again, or the radius squared. Now, what does squared mean? I'm going to put that little 2 up there. That just means that you take the number times itself. So if I had 4 squared, that's the same as 4 times 4, which is 16. If I had 7 squared, that would be 7 times 7, or 49. Whatever our radius is, we're just going to take it times itself. That's all that's saying. Okay, pi times the radius, or pi times the radius squared. Now, it's not the radius times 2, it's the radius times itself. That's why that little 2 can sometimes be confusing. Okay. But right here as well is the formula. A area equals pi, that's the symbol for pi, or that symbol right there. Or you could draw it straight across like that. Both of those are pi as well. I like these two better just because they look more like pi. This looks more like it's 3/4 of a rectangle. I just don't like that. When you see pi most of the time, it's going to be those two. Okay, something like that. So those are our formulas. We're going to keep that in mind as we work through our first practice problem right here. This is our first example. If they tell us that our radius is 6 millimeters, just like in this circle, we want to know what the area, got to fix that, what the area would be. And this time we are going to round to the nearest hundredth if we need to. Okay, so if you haven't really worked much with rounding numbers and rounding decimals, I did make a video of that as well. Feel free to head back and check that out at some point. But if I have, let's go 4.76283, blah, 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 blah. Okay, all of these have different place values. This is the ones. That's the tenths. That's the hundredths, thousandths, 10,000ths, 100,000ths, blah, 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 blah. They just keep on going and going and going. Oh, hit my camera. But this right here, that is our hundredth. If we need to round there, we'll cross that bridge when we come to it. But they're going to tell us that we need to round to the nearest hundredth if needed. All right. They give us 6 for our radius. Well, just like we did with our circumference problems, we're going to fill in what we know. We do not know the area. We're just going to leave that as A. That does equal, just like our formula up there though, pi 3.14 times our radius squared. Okay, we just plug in that 6 for our r, because that's what r is, it's the radius, and we're going to square it. Okay. A then, we'll turn that into an arrow, A equals 3.14, we're going to simplify this just a little bit, times 6 times 6, or 36. That's what 6 squared is. Then, let's do some math here, and once again I'm going to get my handy dandy calculator out, because I do not expect you to be able to do these in your head. If I can't do it in my head very, very quickly, I don't expect you to do it in your head very, very quickly. Maybe you can. If so, good for you. That's awesome. But if you need to use a calculator, nothing wrong with that. All right. So this ends up being 113.04. Now, the difference here is that we are talking area. This has a length and a width. Okay? This is not just a straight line, it is all of the stuff that's inside of that circle. So we do need to have that little 2 above our label. Very, very important in this case that we do have that label. If it was inches, it would be inches squared. If it was meters, it would be meters squared. Miles, miles squared. Okay. But 113.04 we do not need to round because we already have to the hundredths place on our number. Alrighty. Onward! Practice problems. More of them. Let's do this. So once again, using the information that we are given, we need to find the area of these circles, and we're just going to use 3.14 for pi to make things a little easier. So A equals, this case, they tell us 4 inches. So 3.14 times 4 squared. We're just going to write 16 underneath, okay? Because that's what 4 times 4 is. That's what 4 squared is. And then we can multiply, all right? 3.14 times 4 squared, or 16. Boy, my paper got very, very turned there. That was not good. We're just going to go ahead and say 3.14 times 16 on our calculator. And we have 50.24. And again, we need our label and a squared because it is area. There we are. Not so bad. How about this one? They tell us 9 centimeters. Well, area equals, once again, 3.14 times our radius squared. Radius is 9 squared. Down below here again, just to save some space, I'm going to say that's 81 because 9 times 9 is 81. And now we can multiply those together. 3.14 times 81. That gives me 254.34. In this case, centimeters and squared. Let's take a look at the next two down here. We've got 7.5. So area equals 3.14 times 7.5 squared. Now I'm putting it inside of parentheses just because there's a decimal. It looks a little bit cleaner. Otherwise, it looks like this 2 is just attached to our 5. We don't want that. But 7.5 times 7.5, that's 7.5 squared. I can't do that off the top of my head, but it is 56.25. 56.25. Beautiful. So 3.14 times 56.25. Now this is where our rounding comes in, all right? So that times that ends up with 176.625. In this case, because they don't tell us to round, I'm just going to leave it just like this, all right? And it's meters and it is squared. But if they did want us to round to the nearest meter, we would take a look at this and say, okay, if this number right after the decimal point is 5 or higher, I'm going to move this number up to 7. If it is 4 or lower, I can just keep that as a 6. Okay? Because this number technically is closer to 177 than it is 176. If I wanted to round to the nearest hundredth, however, I'm going to look at the hundredth place, and I would look at the number after it. If it is 5 or higher, I'm going to move my hundredth value up by 1. This would be 176.63. Otherwise, if it was 4 or lower, I would just leave it just like it is, 176.62. But they don't tell us to round, so we're not going to worry about it. We're just going to leave our answer just like that. That is fine. Last one here. Once again, we are given the radius. They are being very nice to us. Area equals pi times our radius, 12.2 squared. I don't know what 12.2 squared is. I'm going to get my handy dandy calculator out once again. I'm going to clear what I've got there. 12.2 times 12.2 is 148.84. We'll get rid of that. And then we can just multiply that times pi, times 3.14. If I can type it in correctly, there we go. So we end up with going to be kind of a long number. I'm going to write it up here. So 3.14 times 148.84 is 467.3576. That is millimeters, and it is squared. And we put a box around it because we are done. Beautiful, 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 beautiful. Now, once again down here, I'm only going to do one of these because we are running a little bit long already, but I want to look at this one right here. Okay? If they give us the area in our circumference video, we figured out, hey, if they give us a circumference, how do we work backwards? Well, let's do the exact same thing right here. We still plug in what we know, and we leave blank whatever we don't know. So in this case, we know the A. We know 379.94, and that equals pi 3.14 times our radius squared. Well, just like we did last time, we're going to work backwards. 3.14, 3.14, we're going to divide both sides by that. And once again, I'm going to get my calculator here. Don't know what that is off the top of my head. 379.94 divided by 3.14 gives me 121. So 121 equals our radius squared. Then if we are squaring something, we're just going to take the square root, and your calculator should have a button like that as well. Off the top of my head, I know the square root of 121 is 11. Okay. So 11 millimeters would be our radius. We just double that to get the diameter, and we're in business. All right, that's all there is to that one. Okay, so that is the area of a circle. We talked about circumference, we talked about area. The area is just this fancy word for all that stuff that's inside of a circle or any other polygon. Okay? And we just need to know that the area is pi times the radius squared, or the radius times the radius. Okay? That's all there is to that one. So once again, if you did enjoy and you found this video to be helpful, please do give it a like. That helps me know that this video is helping other people. And if you do want to be notified of future videos, do hit that subscribe button, ring that little bell, and you'll be notified. So thank you again for tuning in. As always, keep an open mind, keep on thinking, keep that brain turning, and try to find something new to learn every single day, because that will make it a success. So thank you for watching. Have a wonderful, wonderful remainder of your day. And until next time, I hope every single one of you will take care.